Awesome. Okay. First off, everyone, I just want to introduce myself. My name is Taylor Thomas. I'm one of the core maintainers of Helm. I also currently work on the AKS team at Microsoft. So I tried to keep the puns to a minimum because puns kind of translate a little bit weird to Chinese, but if they slip in, I'm sorry. And you'll probably just, if they do translate for some reason well, you'll probably just laugh at how bad they are. So title of my talk is Take the Helm. Okay, this is an intro to Helm, and first thing I want to know is how many of you have actually used Helm before? I want to see if anyone's touched it at all. Okay, and of those who have used it, have any of you used it in production? Okay, so a few of you. So the majority of you are new to Helm. So this is going to be assuming you at least know some of the basics about Kubernetes as we talk about the different parts of Helm and how it works. Like I said, the internet's been a little bit difficult, so we'll see if it's back on by the time we get to the demos. First off, I wanted to make a big acknowledgement here. So Michelle Nourali, who is one of the other maintainers of Helm, was going to be the one giving this, but she couldn't make it. So a lot of this content is hers, and I wanted to thank her for that. So big thanks to her. So Helm. Helm is a package manager for Kubernetes. So like if you've used Yum or apt, or any of the package managers, or Homebrew or on a Mac, Chocolatey on a Windows machine. That's what Helm was designed for. It's to be a package manager for various applications and how they run on Kubernetes. It also has some help for lifecycle management. So there's a thing called hooks, which we'll talk a little bit about. So you can do things that run after you've installed an application or before you install an application. And it also allows you to upgrade an application or roll back an application and do some tests as well. So let's cover just some core concepts here. So first things first, you have a chart. And a chart is, it says there, an expert-built recipe for installing an application. So this is like the package itself. You're going to be using a chart as kind of the baseline for what's installed. Values are what you as a user specify as configuration for this application. And a release is a combination of chart and values that get deployed into Kubernetes. So first off, these are the instructions. I thought we might have some internet connection, so we don't. So please don't try this right now. You'll just kill the Wi-Fi. But these slides are online, and you'll be able to download them and follow these steps. It shows how to install Helm. I'm not sure how Minikube works here in China, but if you can get a Kubernetes cluster to try against, just make sure you have a Kubernetes cluster up and running. The first thing that you'll run, and I'll show how this works, is something called Helm init. Helm init is a nice handy way to make sure everything's set up. So if it's your first time running Helm, it's actually going to set up the directories it needs to have the charts and everything that you have to run Helm. But it's very important to know that anytime you're using Helm in your cluster for the first time, you have to run Helm init. Helm init installs a pod called Tiller inside of your cluster to make Helm work properly. So to explain that, what is Tiller? So Tiller is the server-side component of Helm. There's two parts. There's the actual Helm application, and then there is the Tiller application that runs inside of the cluster itself. Like it shows here, it's running as a pod inside Kubernetes, and it talks to Helm, the Helm client talks to Tiller over gRPC. It's the one that's actually doing the work of managing the releases that are inside of your cluster. So remember that release is the values plus the chart. It's managing the entire lifecycle of that inside of the cluster. It'll be changing in Helm 3. I'll actually be giving a talk tomorrow that's, I think, in the same room. That is a deep dive into Helm 3, but this will be going. So, still got me? Okay. So we'll be making sure that we explain that some more tomorrow, but just know that it will be going away, but you need to know about it for now. So next, let's talk about charts. These are application definitions. How many of you who have done Kubernetes have seen like what a deployment looks like? Okay, so most of you have seen what that looks like, where you have the spec and it specifies the image you want to use and the commands you're running. So a chart is generally a collection of these different Kubernetes objects. It also has a some metadata that goes along with it. We have a chart.yaml, which I'll show an example of, that contains metadata and a little bit of the documentation. There's also some configuration in the form of like default values that get installed. Charts live inside of chart repositories. Now, all that a chart repository is a web server hosted anywhere you want that has charts in a tarball, so .tgz, with an index file that shows exactly which charts are available. And so you'll see those everywhere. The most common one is the one that comes built in with Helm, and that's the stable chart repository. And the stable chart repository contains things that are managed by people in the community. These are things like Elasticsearch, and Nginx, and I mean, it's a massive amount of charts that you can find inside of there. So where do you find those? It's actually found at github.com/helm/charts, and you can find both the incubator, which is where new charts land before they're released to like production. It's kind of like the staging environment for charts. Last time I counted, which was about a week or two ago, we had 218 stable charts and 53 incubator charts. We'll show how you can install those. The other thing that's actually really helpful, if you want a GUI to look at this with, there is hub.kubeapps.com. This is actually powered by something written by Bitnami called Monocular. But as you can see in the screenshot here, it actually has a way of visually looking at all of the charts that are available to you. If you install Monocular and things on your own cluster, you can do other cool stuff like you click on the application and install it into your cluster automatically. But you can browse all the charts here and see all their documentation. So like I said, a chart repository has an index.yaml file, has that web server that's available. And the other thing that's been released in the past year is something called Chart Museum. So instead of having to do all the work of packaging up the charts yourself, Chart Museum is an API that you can submit your chart to, and it will automatically update the index and everything for you. It's a great open source project. It's under the Helm umbrella. So if you're interested in that, we can talk some more after. So just a quick recap as we've gone over these different components. Helm is the client. Tiller is the server that Helm talks to. Charts are the package that you're installing. And a chart plus values that you provided are the release object. So with that, let's go to demo time. Let's see if the internet's working first off. Maybe. If it doesn't, then I apologize. We're going to see. Oh, wow. Okay, so assuming the connection is working, we might be able to get this to work. So I'm connected to a Kubernetes cluster right now. Let's see, this will be our test to see if it works. Nope. So this is actually a cluster that if I had an internet connection, this is actually an AKS cluster running in China. That will be fully announced here in just a second, but I was told I could say it was here. So this is actually an AKS cluster running in China, and if we get to the end and the internet's working, I'll try it again. But I can't do the full demo right now, but basically what a Helm does, I can pull it, I have this copied luckily in my slides, so we can try this.
Do you need a hotspot? Give you a hotspot.
No, we're good. We'll just try going ahead. So, So just to show what it would look like, I can't actually run the command, but if you're running, if you want to install an application, you can easily do it with a Helm install. And all it is, so this is a good example right here. So how many of you know what an ingress controller is? Okay, so if you've heard of an ingress controller, generally they can be a little bit finicky and you have to set up things. Well, kind of the general way you can do it is install it with Helm. And this is actually all it takes to install a chart with with Helm is I go Helm install stable, which is the name of the repository, /nginx-ingress, and that's the name of the chart. When you've done that, it actually is good to go, and it'll just be done and actually output. I think I saved the output out here. No, I did not, sorry. But it will output something from the notes file, which is basically gives you next instructions, and I'll show what that looks like in an example directory. So sorry I can't demo, the internet's being kind of a nightmare, but Helm install is all it requires. And then when you want to upgrade your application, it just becomes as simple as saying Helm upgrade, and then the name of your application, and so you might have named it like Ingress or whatever, and then you can say stable nginx/ingress, and that will allow you to upgrade to the next version or whatever you want to do to be able to upgrade that application. You can also do a rollback and say, hey, this thing failed, so I'm going to pull it back. Unfortunately, can't do it yet, so sorry about that, but let's continue with some of the explanation. So a lot of the questions that I get is like, what does this chart look like? How do we put one together? Oftentimes, you're going to just be reusing things that people have already created. Like, there's no need for you to go write your own ingress chart. That's why we have these already provided. So we're going to talk a little bit about how that works. So to create a chart, it's actually Helm create and then the name of the chart you want to do. That dumps a whole scaffolded app. It actually looks like this in the directory. So you'll see this thing that says, here's my app. If you called it Helm create my app, it's going to create a my app directory. And then dump out a chart.yaml, the README for the chart, and then your templates and your values. So first off, let's look at what the templates look like. Inside of your templates directory, your basic ones, like the basic way you get a Kubernetes app running is you have a deployment and you have a service that exposes that deployment in some way. And so what that looks like is if we look at the things here, so you have a values.yaml file. Okay, and the values file contains different things that can be used inside the chart. So if you see here in the chart below, that deployment.yaml we mentioned, it has, right there, it has the name. It says .chart.name. So that's actually coming from the chart.yaml file. And then you have .values.image. Anything that's inside this values file is exposed in that .values object. So .values.image is going to use my company /my app 1.0.0. And so that's going to put it right there inside of the file for you. If you, as the user, have a different image you want to use, like you've built a custom one for your company, then you can actually specify that image name with another values file or something called the set flag. So to show you what that would look like, so if I was going to set that when I was installing, I could say Helm install and then --set image equal to my company image, and then 1.0 or whatever you've had it tagged as, and then stable /nginx ingress. So now that image variable that I showed you will be set as whatever image that you've set it up. So back here, when we come back to this, so if I had set that image, now that image would read my company image 1.0. The same thing goes with all these other values in here. So you'll see like, oh, here's the service definition. There's a port 80. So values.service.port becomes the container port that your application is exposed on. So you can actually do some really cool things with value files. You can specify multiple value files. This allows you to have, like, let's say you have like a base values file for everything that you do, and then you could have another specific one per region. And you can actually specify all of those values files, and it merges them together into a final what's inside of your values. Just some tips for your value files when you start creating them. Always use lowercase keys. So don't have all caps or start with a caps. The standard is that you have a lowercase and generally a lower camel case, like the image pull policy, for your key names. It's always a good idea to make your image configurable because somebody, like I said, might want to tweak that image or tweak specific configurations inside of it. And then make sure you always comment. So the default doesn't have any comments, but when you add a value, comment exactly what that value does. Because people will want to know exactly what each thing that you expose does to the application. So just remember that when you're looking at your values file. So like I showed, you can configure with setting whatever values you want. So this one would set the port to 8080 in whatever app that you're creating. So in that new chart that we just created, when we type Helm create my app, now I could do Helm install set service.port to 8080 and then my app. And you can also pass a completely new values file like that. So the next thing to remember is that you can also have dependencies on other charts. So let's say that your application requires a MariaDB instance. It could be, there's Postgres, there's Mongo, pretty much all the major databases have a Helm chart at this point. So inside of the requirements.yaml file, you can have a list of dependencies that are required to install that chart. And MariaDB is a classic one because it's used in the WordPress chart. And so basically this becomes like your vendor directory of different charts that you need to run everything. And it makes it much easier than having to go pull in each of these manually. So instead of before running your app, you don't have to go Helm install MariaDB. Now you can just say Helm install my app and it's automatically going to install MariaDB with it. And it's going to be part of the same release. So when you look at the release, it'll show you that it has your deployment with your image that you've specified and then a MariaDB instance running in all of its volumes and things. The other thing to know about is inside of the templates, there's also a notes.txt file. The notes.txt file actually uses that same templating from before, the Go templating that you see right here. So you can put that inside of this notes.txt, and when it's done installing, that notes.txt file is printed out after any install or upgrade. And so all of the stable charts have this. And so when you do install the stable Nginx ingress, you're going to get notes out that say, you'll be able to use your ingress now. Here's an example ingress, and here's the port that you can find things configured at. It's really a good place to put like your quick start instructions after you have installed an app. So what you'll find is as you use this at your companies and for side projects possibly as well, that you'll want to explain to users what happens next. So if you're installing a Minecraft server, which I'm pretty sure there is a Minecraft chart, you could then take the notes.txt and make sure it spits out, here's how you connect to your server, and have the exact port name that it needs, or port number it needs to talk to. The best charts out there really have a detailed notes that get printed out after. The other thing to remember is the README file. That's pretty self-explanatory. If you've written code, you've seen a README file. It's the first thing that people will look at. Most good charts have all of their values documented in there. So what each value does and what the default is. It also will describe like if there's any other prerequisites you need before installing this chart, and then it will explain basic instructions of how to install and upgrade the chart and how to delete the chart. So last is the metadata file, which is chart.yaml. It contains some general metadata about the chart, whether that's just the name, but the good ones always have name, a description of what the chart is, the different source code. So for example, for WordPress, it has a link to the WordPress site, so you know where the code is coming from. And it also describes who the maintainers of that chart are. Another important thing that's in the chart.yaml is it contains a semantic version of that chart. So you're going to see like 0.1.0 inside of there. That's what's used when you're installing a specific version. So when you go Helm install, you can actually install any number of versions of an app, and that is specified in the chart.yaml file. Also, there's a keyword section in there that allows you to say what it's searchable by. So you could want to install WordPress, but you want people to be able to find it by blog. Like if I want to search for that chart and find if it's a blog chart. So you could put a keyword as blog, and if someone says Helm search blog, that'll be one of the options that gets printed out. Okay, so last but not least, a helmet is the funny term we use to refer to users and contributors to Helm. If you want to become one, I have a couple pro tips for you. First off is what's about the Helm community here. So there's lots of contributors. Last time I checked, there were 391 different contributors to Helm on GitHub. We have 2 main Kubernetes Slack channels, Helm users and Helm dev. Helm dev is for people who are working on Helm itself. Helm users is for the people who are actually just using Helm as a project and not writing any code for it. There's also, I forgot to mention here, the Charts channel, and the Charts channel is all about people who are writing charts that you want to share with others. They always keep a good conversation going in there. The other thing to know about is that we have weekly updates and demos at sometimes the SIGApps meeting, Kubernetes SIGApps, and we have a public Helm developer call. It's at 09:30 Pacific time on Thursdays. Now that's going to be at a weird time here, but it is recorded and they're available online. And then if you want to see the documentation for Helm is available at docs.helm.sh. And that has all this information that I've told you and even more about advanced configuration. Because you might have questions like, how do I get this started if I have RBAC enabled in my cluster? That's one of the first things people will run into. There's instructions on how to do that on the Helm doc site. And then just for everyone here, we have these helpful links just in case. So there's the main Helm website, helm.sh. The quick start is right here. Once again, these are actual links you can click on in the slide deck. You can download it from the schedule page. But there's the quick start. That's how you just get up and running really quick. And then the docs that I mentioned. And then if you want some tips and tricks, this is a YouTube video of people who gave some really interesting examples on what to do with charts and when you're writing them. So let me see. Before I take questions, I'm going to see if we have the internet, and then I can show you. And if not, we'll take questions. Okay, internet is not working. So any questions about Helm that you'd like to ask? Yes?
If I want to contribute a chart, should I just open a GitHub PR, or should I talk to somebody in Slack?
Yes, so I would actually do both at the same time. So
right.
You can always open a PR against anything Helm related, charts or the Helm project. So if it's a chart, you're going to want to make sure it is well documented, so you have a well documented README. Look at any of the examples in the stable repository and kind of mimic those. So make sure you have everything documented, you have a good notes.txt, and that it follows the patterns that you see in other charts. And then I would also talk to the chart maintainers in the charts channel on Kubernetes, especially if you don't get any traction. There's a lot of work that goes on inside of there. And so sometimes it just gets lost. And so you just don't feel bad about pinging people. It's good to do that because then we're like, oh, sorry, and we'll go take care of it if we miss it for some reason.
And a follow-up question is that how do you review the chart? Because do you have somebody familiar with the software and to review to make sure it's generic enough, or how do you make sure it's gonna accept it and it's appropriate to be shared?
Yeah, so this has actually been something that's constantly been evolving. The way it's going to happen is that one of the main chart maintainers will look it over for consistency and making sure it's a well-developed chart. But then whoever's managed the application is generally one of the maintainers of that chart. So we've been trying, for example, Elasticsearch is one, I think, where the people who actually write Elasticsearch are one of the people who maintain the chart to make sure that that it's good from the software perspective, because we don't have knowledge of every single application that's in there. So the chart maintainers will just make sure that it is well maintained and it's well built, I should say. And then from there they'll just double check that it's good with. If you are the author of that software, then they'll be like, okay, then as long as you're okay with maintaining this. So if anyone else from the community says, I want to change your chart with this, that you'll be able to help review it.
Thanks.
Yeah. Any questions? Yeah.
Thanks for the presentation. So my question is about what if I remove the Helm backend server tiller, and would I be able to get my metadata of my deployment back after I reinstall, or having a new tiller up?
Yeah. So the actual information on a release is stored in the kube system namespace on your server. So it's all compressed down and then stored in a config map. So if you look inside of your kube system namespace when you have a running tiller, it's going to list every single one of those config maps that you have, including past versions that allow you to roll back to them. And then if you ever delete tiller, whether to just perform maintenance or if you need to roll it, it's just going to spin up and it's going to look in the same place and pick everything back up. So you're not going to lose state if you delete tiller on accident or if you have some sort of issue where it goes down.
Thanks.
Yeah. Any other questions? Okay, I think that's it. Oh wait, one more, sorry.
Quick question. When will Helm 3 release?
So that is something that you should come to the talk tomorrow for. So I'll be here at about the same time. We'll talk more about Helm 3 and roadmap and when things are coming out and what the big features are going to be. Okay. Hey, thank you very much.